Hi everyone and welcome back. In this second part, we are going to focus on the directly accessible gold that we collected last time. I have here about 2/3 of a 1 liter drawer. All this comes from desktop and laptop computers, monitors, printers and obsolete scientific devices from my university. So we are going to process chemically the content of this drawer. But before that, I would like to thank all the people who donated their electronics. In particular, I would like to thank Polly Burns, Adrien Conangle, Andrea Freitas, Claudia Vansovska, and Elena Skripnikova. Before anything, you should prepare some stannous chloride in order to detect the presence of precious metals in the acids after they have processed the electronic scraps. Watch my tutorial on how I made mine. The first thing we need to do is to dissolve all the base metals such as iron, copper and nickel, and for this we use nitric acid. If you need to, watch my tutorial on how to make nitric acid from household items. Now I see many tutorials in which people tell you to use 1 part of nitric acid mixed with 1 part of water. This is totally meaningless. It depends on the initial concentration of your nitric acid. The point is that we don't want to use an acid that is too concentrated. Why? Because if it is too concentrated, it won't react. It needs water. As an example, check this video in which I had to add a lot of water to my nitric acid for it to be able to react with copper. Also, if it is too concentrated, it could nitrate some of the parts that are in the batch and lead to a spontaneous explosion. Some of you may remember my tutorial in which I showed how easy it was to make nitroglycerin. We definitely don't want to synthesize a similar product in here. So, we don't want the acid to be too concentrated, but we don't want it to be too diluted either, otherwise it will take forever for the metals to be dissolved. A good compromise seems to be a concentration of about 40% by weight, so this is what I'm going to use. The first thing we need to do is to determine the concentration of our nitric acid. The nitric acid I make typically has a concentration of 95%. But I made it about a year ago, so its concentration probably decreased because it slowly decomposes into nitrogen dioxide, oxygen and water, which dilutes it. So I need to measure the concentration again, and for this I'm going to use this precision syringe in order to measure the weight of 1 milliliter of my nitric acid. Now, as you can see, it fumes red, which means that the concentration dropped below 95%. But since it fumes red, it should be at least 80%, I believe, maybe 85 or even greater. So let me measure 1 mil. So let's see. Oh, I have an air bubble, so let me do it again. Alright, so I don't know if we can see on the camera, but I have exactly 1 mil. And let us measure the weight. So when we calibrate the scale, I don't know if we can see the numbers on the camera. Oh, it's not, yeah, it's calibrated. So $3.72 grams, but I need to subtract the weight of the syringe, of course. Which is 2.28 grams. So let us see what this tells us. Also, we need to measure the temperature of the nitric acid. So let me wait a few seconds for the temperature to stabilize. Alright, that should be good enough. And I read 29 degrees Celsius. It's pretty hot today. Now let us do some simple calculations. My measurements reveal that the mass density of my nitric acid is 1.44 grams per milliliter, and this is for a temperature of 29 degrees Celsius, which I'm going to approximate as 30 degrees Celsius. By doing a simple Google search, I found a table that gives the concentration of nitric acid as a function of mass density and temperature. Note that kilograms per liter is the same as grams per milliliter. So, if we search in the 30 degrees column for the mass density of 1.44 grams per milliliter, we see that it corresponds to a concentration of 81%. That's the concentration of my nitric acid. Now, your nitric acid will probably have a different concentration, so let us call it C, and let us call M sub C its mass, and M sub P the mass of pure nitric acid molecules that it contains. By definition, the concentration is the ratio of the mass of pure acid to the total mass, M sub P over M sub C. What we want to do is to determine the mass of water, M sub W, that we need to add for the concentration to drop down to 40%. This means that we want the ratio of the mass of pure nitric acid, M sub P, to the total mass after adding water, M sub C plus M sub W, to be equal to 0.4. By dividing the first equation by the second one, we obtain the mass of water that we need to add. However, we will be working with graduated beakers, so it is more convenient to work with volumes rather than masses. So we can easily convert the previous formula by using the definition of the mass density. The density of water, d sub W, is equal to 1 by definition, and the density of my nitric acid is 1.4 grams per milliliter. This way, we directly obtain the volume of water that needs to be added as a function of the volume of acid that we want to dilute. Plug in the number into the formula. I find that, in my case, the volume of water that I need to add is 1.48 times the volume of acid that I want to dilute. So I diluted my nitric acid according to the calculation that I just showed, and now I'm going to fill up this jar until everything is covered. But first I'm going to put it into this dish in case there is an overflow. I don't want to lose any of the product because, well, we want to recover several metals, not only the gold, but the nitric acid is going to dissolve maybe some silver, and we want to be able to recover it later. So in case it overflows, I still want to keep what may fall into the dish. I realized that it wasn't a good idea to put the circuit boards, the pins and plastic connectors into the same batch, as it makes it hard to separate the gold foils from the other elements that have the same size. So don't do that mistake. Here I'm quickly starting over with circuit boards only. Make sure that you removed all the components from them. It's a small batch, there won't be much gold, but that should be enough for the demo. So here again I have my nitric acid that I diluted according to the calculation that I showed. So it has been reacting for about 2 hours, and apparently there is no more reaction going on. So that means that either all the base metals have been dissolved or all the nitric acid has been consumed. So in order to check that, we can take a piece of copper and put it in the mixture and see if we see a reaction. And I don't know if we can see it on the camera, but I can see a reaction on the copper. So that means that the nitric acid is still active. As a result, all the base metals have been dissolved. So here I have a plastic pan that I bought in a thrift store for $1, and I drilled some tiny holes. So I'm gonna put it on this glass dish and filter all the nitric acid, all the solution that is left. Right. So make sure you clean all the boards, make sure all the gold foil are off of the boards. So after I rinsed all the circuit boards and the strainer, all the gold foils ended up in this dish. So I'm going to transfer it into a beaker, as it will be more convenient to decant the solution. Now let this sit for a few minutes so that a maximum of the gold foils can go to the bottom, and then we can start to decant the solution. So after filtering out the nitric acid, rinsing with water, decanting and filtering, I ended up with this muddy gold powder. So I believe that the mud is just some plastic particles, but I can't separate them from the gold. I can't dissolve them, so I'm going to process the thing as if it was clean, and we will see if it works. So now what we want to do is to dissolve the gold in aqua regia, which is a mix of nitric acid and hydrochloric acid. So we need 68% nitric acid, and for this I am going to dilute my 81% nitric acid according to the formula that I derived earlier, and then I will add 3 parts in volume of 31% hydrochloric acid. This is how we make aqua regia. So here my aqua regia is ready, and what I'm going to do is simply to put this coffee filter with the gold and mud directly into the mixture, and it will dissolve the coffee filter. And also what we may want to do is to put it on a hot plate. So I let the aqua regia on the hot plate for about 1 hour, and now I'll let it cool off, and let's see if we can see on the camera the solution cleared out and the mud is at the bottom. I can't see any more gold foils in that mud, so apparently all the gold has been dissolved. So let us make a stannous chloride test in order to make sure that the solution contains our gold. Well, it should, because gold doesn't disappear like that. So just take a piece of paper, tip it like this, and put 1 drop of stannous chloride on the white part here and let it go down. Well, maybe 1 more. No, that's okay. Let it. You see how it turns black? This indicates that our solution contains gold. So now we want to filter the solution, but if we filter it like this, it's gonna eat the coffee filter paper. So what I'm going to do is to put it first in a bigger jar, and then I'm going to dilute it by adding 3 times the volume of water. Okay, so here I have about 100 mils of aqua regia. I'm going to add water up to 400 mils. Okay, so here I'm adding distilled water. Alright, so now I'm going to filter the aqua regia. Alright, so the solution has been filtered and now it looks nice, very clean. Let me do another stannous chloride test. Remember, the first time we did the test, the aqua regia just reacted with the gold. It hadn't been diluted yet. But now this one has been diluted. I added 3 times the volume of water. So let's see if we can still see a reaction with the stannous chloride. See, yes, still turns black. Okay, all right, now what we are going to do is to precipitate the gold, and for this we are going to use some sodium metabisulfite. Okay, it's very cheap. I don't remember the price, but with a bag like this you will have until the end of your life. Alright, so now the question is, how much should we put? And for this, well, it's hard to tell, so we don't want to put too much, because otherwise the metabisulfite may precipitate itself if the solution is saturated, or maybe it can precipitate some impurities that are with the solution, I don't know. But we also want to make sure that we put enough. So to make sure that we don't put too much, we can start with 1 teaspoon, and then we will do a stainless chloride test to see if all the gold has precipitated. Alright, now it may take a while before the gold precipitates, and it is usual to wait for 1 hour or even more. Okay, so I'm gonna pause the video here. Wait, we see already a color change. Alright, that's good. That's good. Okay, let me pause the video and then we'll see in 1 hour what we get. So I actually let the solution rest overnight, and now we can see that some ugly brown powder formed at the bottom, and that powder is supposed to be pure gold. So we are going first to decant that solution, but before that we want to make a stainless chloride test in order to make sure that all the gold has been precipitated. So again, let me take a little bit of the solution in it and drop, and here we can't see a change in color, so this means that all the gold has been precipitated. So pour slowly the liquid, making sure that none of the powder at the bottom goes into the large beaker. You can see some floating impurities. Alright, and then rinse with some distilled water. So let it rest a little bit and decant again. So yeah, this is how much we got. It's hard to believe that this is gold. Okay, so now I'm going to transfer this into a crucible so that we can melt it. Alright, so everything is in the crucible. There's not much, and it will be even less when it will be melted, but remember that was a very small batch. Alright, we are about to make the alchemist's dream come true.
Then we put it in water to cool it off. And then in sulfuric acid to remove the borax. Okay, let us measure the mass of our little bead. 1.44 grams, so that's not much, but once again that was only a small part of the batch. We also have some more gold in the golden pins and also in the ICs. We also need to process the silver, the palladium, and the platinum, so we will do this in the upcoming videos, so stay tuned. Don't forget to subscribe to my channel if you haven't done so that you will receive a notification when I post the next video. Thanks for watching.